internet. It's just driving me crazy. I don't know. Maybe. Let's try that. Yeah. Yeah. Can you do it like to the side? Is that gonna mess up the antenna?
That's all right.
Yeah.
Yeah.
Okay. Yeah. Powder 80s businesswoman. Oh yeah, I had.
Yeah, I didn't remember that until just now, but yes, I think that was in the instructions.
Yeah.
That makes me wish I was not doing second day here.
I know, right? I just had to go with the. Makes me wish I hadn't thrown my. Can everyone hear me when I'm talking this quietly? I was just saying, I threw my mascara out after my second round of pink eye. Oh, whoops. And I haven't got a new one, and I feel like naked without it. One last time, as we've got a few more people coming in the next 3 or 4 minutes, if you have any questions on these first few steps, let me know. Anybody need help getting things set up? Okay. Yes. You can also, if you go to this site, you can see all the steps on your screen. Let's see, is that a little better though? Oop. Hand here. Okay. Perfect.
I'm just trying to figure out where to.
Yeah, that's perfect.
Navigate to
So
your thing.
did you save, do you know where you saved that? Did you download and save if you go to step 1, did you clone or download the repository?
No, I don't know how to do that.
That's fine. So you click that, and you're going to download the zip file and save it just in your documents or somewhere you can navigate to. It looks like it went to downloads, but move it somewhere you can get to. Perfect. Anybody else help getting things set up? I saw another hand. Yep, sorry. Yeah. Mm-hmm. Yeah, yeah. Zuhr. Uh-huh.
And then just
Slash SDOH dash clusters. Yep. Great. Anybody else? Questions? Getting things started? Okay.
What's happening up there?
No, it's not on my laptop, so I guess it's this thing. If you have Jupyter Lab open and you're not familiar with the command line, we're going to be using this a little bit today, so you may want to go ahead and do File, New, Terminal, and see if you can navigate to wherever you saved this document. For people who aren't familiar with working at the command line, this may be one of the trickier steps, so if you want to play around with that the next couple of minutes, let me know if you need help.
There are a couple seats over here and a couple up front, if anybody needs them.
I know, tell Tommy. More people at my talk than whatever you want to.
A couple seats in this row, if y'all need them. start with the PowerPoint?
Yeah, take time.
A couple more minutes.
So, go ahead and start.
No, whatever you want. Good morning, everybody. We're going to start our presentation because Erica's got a ton of stuff to go over. And I'm going to do just a couple, don't panic, just a couple little business slides to give you some context for what we're doing. But most of this is going to be hands-on code stuff. I think we're having to advance it from here.
Yeah, I can do it. Just let me know when you need next.
So this is Erica. I'm Catherine. We're from a company called On Life Health. We do total population health and wellness. You can go ahead and do one more. Yeah, total population health and wellness. There's another seat over here. You guys need them? And there's a couple of chairs that you could drag into seats if y'all need them.
Yeah, and if you want to take my seat also.
Yeah, we're taking up quite a bit of room up here.
Yeah.
So we're headquartered in Nashville, Tennessee. We do wellness programs primarily for other companies, mostly work with health plans. We do have a couple of direct employer contracts. And we want to talk to you a little bit about today about our experience for our members and how it translates and how machine learning kind of translates into how that experience is affected for memberships. Oh, thanks.
I'm not doing a good job on this.
And Erica's going to go a little bit more into our problem statement to set up what she's going to go over with you today. But one of the things we started working on a couple of years ago was having a more personalized experience for our members so that we can have maybe more engagement from them, try to give them something that's a little more personalized as far as the recommendations go, so people are more likely to interact with things that are more personalized. So we embarked on this new UI for our members where we've got these large cards, and then the cards represent the next best thing to do for that member. So as the big card gets dismissed or gets used, the next card kind of comes into play. And we wanted a way to make that a more personalized experience. So hired Erica and basically said, hey, you've got the big personalization project for this year, go. And that's one of the things we'll talk about as challenges as we go through this. So asked her to think through how can we look at our membership and come up with a more personalized experience. How do we maybe have personas, for example? And so let's go to one more slide. So she did a clustering analysis that resulted in these personas that we have. We've got the names for them that are characterizing, kind of capturing the essence of who they are based on their average characteristics. We have some engagement insights. And that allows us to promote programming and content based on these personas to people so that it's a little more personalized for them. So one of the other things that we're going to do today is talk about social determinants of health, and that's the actual analysis that Erica's going to go through with you guys. So social determinants of health, if you haven't heard of that, is a concept that good morning. Is a concept that everything in your environment influences your ability or likelihood to make good decisions related to your health. So for example, if you live in an area known as a food desert, that's a really common thing to talk about right now. It means that within a certain radius of miles that you don't have access to food that is fresh produce, fresh meat, fresh dairy. It means you're more likely to have access to food through convenience stores, vending machines, and mostly processed items. So if we're talking to somebody and want to affect their ability to make good decisions related to food, doing education around, this is always an example I used to use when I was a coach, eating the rainbow, which is then turned into a Skittles campaign, so I may get sued if I continue to talk about that. But we talk to people about eating the rainbow, making sure they've got 5 servings of fruits and vegetables every day of a variety, colors, and textures, because then you're going to get all your vitamins and minerals. That is such a disconnect for somebody who doesn't have any access to non-processed foods, fresh produce, fresh dairy, fresh meat. So that's not maybe the best next thing for them to do as far as addressing their next need. So we are working on, and this is what Erica's going to show you, how to use social determinants of health data, which is publicly available, and things like, in addition to food deserts, it might be access to primary care. So they look at the ratio of primary care physicians to people in the community to see if you've got a higher ratio, that means you've got probably lower access to care. Things like high school graduation rates, if you live in an area that's got sidewalks or a safe built environment so that you can recreate outside, all these different things that will affect your ability to make choices, healthy choices. So put that in front of Erica and the rest of the team and just said, hey, we want to also be able to do something like that for social determinants of health. So now we have something that's related to kind of how they interact with our wellness platform. And then we also want to have something that tells us what is the next big card that we should display to them based on social determinants of health. So that's what she's going to take you through today, and then we'll end up at the end kind of talking about challenges and successes as we've worked through this. That's really that last mile kind of concept. Anything else you want me to cover before I?
No? Perfect. Thank you.
All right, take it away.
All right, I'm also going through just a very, very few slides before we get to the code, which I know is the more interesting part. So the problem statement that Catherine talked about, our initial problem statement, was really about member level or user level personalization, but since we can't share our members' personal health data with you to recreate those clusters, we're doing clusters of US counties based on the social determinants of health data. So our individual samples that we're working with are going to be all of the counties in the United States, county and county equivalents. So our problem statement for today is to create data-driven groups, also known as clusters, of US counties based on publicly available data on the social determinants of health, and the goal for that is to be able to provide better health and wellness content to our members based on what their social determinants of health are. So for those of you who aren't familiar with clustering, I wanted to do a super quick kind of conceptual overview. So you can see in the graph on the left, we have two variables, a bunch of data points. We don't really know much else about them. And then what we can do when we apply clustering, the algorithm that I'm going to use today is one of the most basic clustering algorithms. It's called k-means. K is the number of clusters. So you apply k-means. Pretty much all you have to tell the algorithm is k, which is the number of clusters. So we apply k-means with k equal to 3 to this data set. And what we get back are these three groupings of kind of the natural groups of the data, 0, 1, and 2. So from here on out, I'm going to assume at least a high-level kind of understanding of clustering, what it means, and that's our machine learning algorithm we're going to be addressing. Any questions on this so far? Cool. Okay. So a little bit of an outline. So most of the concepts listed here are fairly straightforward, but there are many, many ways to do all of them. Hopefully none of them will get you fired. I Googled to see if there was a less grotesque way to say there's more than one way to skin a cat, but there's really not one. Like, there's no other saying that means the same thing. And you know, it brings in a cat meme, so it's good. So, you know, there are more solutions literally every single day with the speed of open source development, so we'd really love for this to be an open forum if people have done some of these same things. These are haven't used and haven't even heard of, so if you have something that's been a great solution for you, let us in the room know. We'd love to hear about it. So yeah, keep it an open forum. Question, comments, let us know. Okay, warning, these next 5 or 6 slides I'm going to fly through. They're terrible slides. They have way too much text on them. They're mostly for reference. I'm going to provide them later, so don't try to take them down. It's just everything I wanted to cover in this talk before I realized it's an hour-and-a-half talk, not a semester-long class. So it's just a super high-level overview, because then at the end I want to get a poll and see what people are more interested in. So flying through, I'm sorry, I'll give you the slides later. Okay, so version control, I strongly recommend Git if you don't use it already. You can start with the 4 basic commands of just git clone, git add, commit, and push. And then add branching later. A lot of the tutorials start with branching. I think that's too complicated. Just start with your master branch and then go from there. Organization is key. There's something called cookie cutter data science that I discovered about a year ago. It has a great directory folder structure. And I'm a little bit obsessed with it. It keeps your project organized. Of course, you want to stay flexible. I'm a new mom, and the best parenting advice I received so far is stay flexible or die, which I think applies to data science as well. But mostly, I just wanted an excuse to put up a picture of my cute baby. Custom packages and modules. These are going to help you from copying and pasting code. A custom module, I always get them confused. A module is just a Python file, and then a custom package is just a folder or directory with some Python files in it. And we'll go over an example of one of these at the end. Data, can't have only one cat meme in a talk. So data, it's why we're all here. We want more of it. It's super interesting. But our primary tenet here that took me a while to learn is that data is immutable. And a lot of this is adapted from the cookie cutter ethos. Once you have that raw data set, you don't want to touch it ever. This is one place you don't want to be flexible because you always want to be able to go back and see that single source of truth, what you started from, even the good, the bad, the ugly, what was missing, what was good, what was terrible. Testing, I don't mean testing in the train, test, set, machine learning sense here. I mean testing development. Using these kinds of tests will allow you to know automatically if your code is broken or not, which is a pretty useful thing when you go in and make changes. You just hit one button, and it'll show you green if everything's working, and red if you mess something up. Model training and selection, pandas and scikit-learn are probably the two most fundamental packages for analytics and machine learning in Python. Who is familiar with pandas and scikit-learn? Okay, cool. We will be using them today. Documentation, Markdown at the most basic level, Sphinx if you need something a little bit more advanced. Persisting, deploying, and maintaining your model. Pickle saves or serializes models so you can use them later. You don't have to retrain them. Docker is a lightweight virtual machine for deployment. You should use it. We don't yet, so let me know how it goes if you do. We'll hopefully be there soon. Okay, so based on that flying through overview, I wanted to get a feel for if people are more interested in the training, model selection, and visualization. I'm planning to go over everything, but I can spend more time on kind of one part or the other. So are you more interested in that training, scikit-learn, pandas, model selection, visualization, or are you kind of bored with that? You'd rather fly through that and focus on really that last mile, like getting some command line scripts, the testing, the logging, or just who's for part A? Who's more interested in spending a lot of time on the training, model selection? Okay. All right, what about B? Great, half and half. This is what I get when I set myself up and say, it's open to beginners, but also, all right. So I'll try to, explain some of the more intro concepts as I go through. Please, please, please stop me with any questions. If you have a question, chances are someone else does as well. See, yeah, who wants more cat memes? Bad news, I only included 2. I ran out of time. Are there, for part C, are there people who are kind of equally interested in both things? I mean, okay, at least one. Okay, so finally, I did want to say one thing here. The title of our talk is The Last Mile of Data Science, and I don't want to say it's a misnomer because it is the last mile of getting it into production, but you're going to see a lot of the things I focus on here happen throughout the process, and that's because to get your work into production, you really need to set yourself up correctly from the beginning, and arguably that first mile is even more important where you're defining your problem statement, making sure you have the right data, collecting the right metrics for your outcomes, setting a good foundation so your last mile is hopefully the easiest part. Okay, questions so far? All right, so finally, moving to our code here. So I'm going to run through, as I mentioned a few times as people are coming in, 1 and 2 here were the requirements that we sent out. Steps 3 through 6, I'm going to run through really quickly here. And then I'm going to take just a couple minutes. If anyone has help, I'm especially worried about step 5. If anyone needs help with these, please let me know, because you're going to be missing out on following along with a lot of the really cool stuff if you're not in the right directory in your terminal, and it's going to make it a lot easier. So getting started, so hopefully you've done steps 1 and 2. If not, you can work on that in a few minutes. If you're on a Mac, go ahead and open a terminal. If you're on a PC, you'll want to open the Anaconda prompt, and you can find that on your PC just by searching for Anaconda prompt. I don't have it because it's not a PC. Okay, and then once you get your window up, type Jupyter, misspelled with a Y. I've used this Jupyter Lab so much that when I see Jupyter spelled like it's supposed to be spelled, I'm like, oh, why? People can't spell. What's going on? It's a planet. Come on, people. Okay, so type in Jupyter Lab and hit enter. How many people have used Jupyter Notebooks before? Pretty comfortable with them? Okay, have you guys used Jupyter Lab? Anyone? Okay, a few people. It's the next generation, and I love it. Another thing, like cookie cutter data science and one of the things it lets you do is have a terminal open in the same window, which makes switching back and forth really easier. There are a few other benefits. You can do most of what I'm doing in Jupyter Notebook if you prefer and you don't have Lab installed, but you'll just need a terminal open up alongside or a Windows command prompt. Okay, so from here, we want to File, New, open up a new terminal, and you can everyone try typing PWD and hit enter. Does this work for anyone who has a PC? I tested this before with my coworker and then I forgot. It works? Excellent, okay. All right, so everyone's got a terminal open, that's good, and then we want to navigate to, in this left-hand pane, wherever you saved this, your Git repository that you downloaded, either cloned or downloaded using this green button, download zip. You want to navigate to wherever that is. So mine is in Documents, Social Determinants of Health Clusters, and then I'm going to go ahead and navigate to that Notebooks folder, open up 2.0 clustering notebook, and then we're going to go ahead and execute this first cell that has all of our imports in it. So you can execute either by hitting that little play button, or if you hit Shift Enter, it's a shortcut to execute. So it'll take a minute for imports, and if you get a little 1 up there, I just did it again, so now it's a 2. If you get a little 1 up there, it means it's executed correctly. If you get red or errors, something's going on, let me know. So I think, is this everything in my, oh, yes. And then the other thing we want to do is go ahead and install PyTest. So go back to your terminal and type conda install PyTest and hit enter. And that's going to take a minute. It'll ask you if you actually want to install it. You'll have to type Y and hit enter and let that be running. So let me check. And all of these instructions are at the top of this social determinants of health repository. I'm checking my own instructions to make sure I did everything I wanted to do. Yeah, okay. Okay, so the next few minutes, oh, right, and then on the terminal, we want to where the directory where we saved our social determinants of health clusters folder is so that I can run things from that terminal. So you do that using the cd is change directory. So we're going to type cd, and then you want to, whatever the file path is for your social determinants of health folder, you're going to want to type that in and hit enter. And this gets a little tricky because typing an exact file path is hard. So if you hit a tilde and then a slash and then hit tab, it'll tell you what directory you're in and what's next. So that should be your home directory. If you've stored social determinants of health in documents, you can just use tilde slash documents and then wherever else it is. And anytime you start typing the name of a folder, if you hit tab, it'll auto-complete for you. So I've got cd tilde slash documents stoh clusters, and I'm going to hit enter. And now when I do that pwd print working directory, I can see that my working directory where I am right now is that highest level social determinants of health clusters. So who's familiar a little bit with working at the command line? Okay, good. So we've got a lot of people that are pretty comfortable with this. It seems really foreign and scary if you're not used to it, but I promise it'll make your life a lot easier, and that's one thing I'd love for you to get out of this tutorial. It'll also make you faster and a more productive data scientist. And make sure you've worked through steps 1 through 6. If this is easy to you, take a look at steps 7 and 8 to play around a little bit. And anyone not in the correct directory need help, don't be shy. It'll be a lot more interesting if you're in the right spot. I know it's tough. Nobody? Yeah, okay, good. Someone broke the ice. Or ask your neighbor. If you're bored and you don't want to do the extra credit, help your neighbor if they need a lot. Okay.
I've been having problems with my version of Python because I updated my Mac and apparently Mojave or whatever doesn't.
Let's see.
So I have Python 3.5 installed.
Cannot import time delta.
And then I tried restarting the kernel with the different.
Yeah. Try conda root. Huh. That is odd.
I can also just like Google it because I don't want to take up
Yeah.
all the time.
I unfortunately don't have an easy fix for that one. Try Google. My recommendation would be if you want to follow along with the notebook, you won't be able to do everything, but you can open, like in Google Colab, have you used their online notebooks? Okay, if you have a Google account, you can just upload this notebook and then you can run it there and like everything should be working.
Okay, I'll do that.
Yeah, sorry, I don't have a quick fix for it, so. Yeah. Okay, 0 for 1. Anybody else need help? Everybody in your terminal and social determinants of health? Good to go? Okay, awesome. Oh, yeah. Thank you. Okay, so now that we've got everything set up in Jupyter Lab, I'm actually going to trick you, and I am going to go to just a file browser for a second to show you how I get started with every project. And I do that by creating a cookie cutter data science project. It's just one command that you run in your terminal or your command prompt, and it creates this really nice folder structure with some boilerplate code, so you're all set up and ready to go. So this is an example of what a cookie cutter project looks like before you touch anything. It has all of these nice folders, has your data folder, self-explanatory, docs. This is a Sphinx project, I believe. Models, this is where you would store your saved models. It has a place for your notebooks. It has a README markdown file. References and reports for your PowerPoints, your Word documents, any figures you create. And then it has your source folder for your actual code, and we see we've got data, features, models, and visualization. And don't let this data folder within source be confused with the higher level data folder. This one is for code relating to the data, and then this higher level folder, we're keeping our actual data in. And then the same with source models. This is code related to models, whereas that higher level directory is where we're going to keep all of our saved models. So setting everything up and keeping it organized like this will really help you in the long run as you're trying to get things deployed. Yeah?
Is there a folder for like SQL files?
Yeah, so I put that in source data because it's code related to data, and then I go back and forth. I don't have a set thing whether I make a SQL folder within source data or sometimes I just save the SQL files there. But yeah, that's a good question. And the cookie cutter, the really cool thing about it is you can create, so if you always have SQL and you want to make a source data SQL folder that's always there, you can modify the template and then you can have your own template that you can create with one command every time. Or you can just make your data folder or your SQL folder. Any other questions? Okay, so this is how I start my projects. You'll see that my folder structure looks a little bit different from that, but not too terribly different. So now we're going to go to this 2.0 clustering notebook, which hopefully is running for everyone. And this is a little table of contents outline here. This is another super nice feature with Jupyter Lab. It is an add-in, so you have to install it. I think it's called Jupyter Lab TOC. But whenever you do Markdown, Markdown is it's just a plain text way to get a little bit of formatting in your code for people who aren't familiar with it. So you can change any cell to a Markdown cell, or you can let it be code for so when you do Markdown, it'll automatically create a table of contents. So you can kind of see here the outline of what we're going to cover today. I'm going to show you machine learning in one line of Python, data clustering results, and then using a custom module or package. So machine learning in one line of Python. I started copying and pasting this from the middle of my code, and it was 5 lines, and then I'm like, it's pretty easy to make it into 3, and then realized I can actually jam it all into just 1 line. Yeah, question?
The table of contents thing,
Mm-hmm.
Is that a map thing or is that a Jupyter Lab thing?
It's a Jupyter Lab thing. It's a Jupyter Lab extension, they're called. So since it's open source, other developers in the community can write things that work with Jupyter Lab. So someone independent wrote this table of contents extension. Install it. Okay, so this 1 line of Python is in fact a full machine learning model in just 1 line. We're reading in our data here using pandas. I'm going to scale the data using a fit transform. K-means is my clustering algorithm. I'm going to fit it and predict it. You can hit Shift Enter or that play button to run, remember, and then we can, oh, you know what? Sorry. I didn't clear all of my outputs, so all of the answers are here already. I want them to show up as I go through the code, so let me do that real quick. Maybe. Of course, it's taking its time. Any other questions while we're waiting? Yes.
Do you know the Jupyter Lab, if it can automatically activate an environment if you've made a virtual environment?
Yes. It can't do it automatically. This was in my first even longer version of complicated slides, and I'll email you my slide on it because it's more of a pain than it should be if you reach out after. You can use Jupyter environments. There's a pretty good Stack Overflow question on it that's a little fuzzy. It's not automatic and out of the box, but there is a way to do it without too much of a headache. Excellent question. The question is whether you can use Conda environments in Jupyter Lab, and the answer is yes, but you'll need to do a little Googling and install a couple things. Okay, so we can see here that my predictions, it's actually an array. It's got some numbers, so these are cluster numbers out there. It actually did something. I did a full machine learning project in 1 line of Python. And that's a great title for a blog post, but it doesn't help us out a whole lot in real life. There are a lot of problems here, the least of which the code is not very easy to read. That analysis is not reproducible. We would have to retrain the model every time we want to make predictions. We have no way of understanding the significance of those clusters or using them in our business. And where did that 6 come from? Why did I pick it? And then we also cheated by doing some of the data ETL outside of the script, which if you're familiar with the 80-20 rule, is 80% of the work. We didn't actually do that much ETL, and I could have just taken the raw file and done the predictions, but. As long as you have some sort of array, that's okay. Like if the numbers are different, that's fine. So K-means the way it initiates, the clusters are going to be in different orders every time. So you get the same clusters, but cluster 1 might be cluster 5, because that's random initialization. So as long as you're getting something here, that should be fine. I'll tell you when the answers should be exactly the same. From here, for a while, they should be exactly the same. Okay. So moving on to our data, we're using data from the county health rankings. It's a super nice data set. If you're in healthcare, I definitely recommend taking a look, especially if you're interested in social determinants of health. It's fairly clean. So this is just the raw file that I downloaded from that website. This all is in push to the Git repository, which normally I would not recommend, but these are pretty small publicly available files, so I just put everything in there for the ease of use today. But with the default cookie cutter project, your data is actually in Git ignore, which means Git won't push it unless you force it to, which is nice if you have sensitive data. Okay, so this is what, for people, who is not super familiar with pandas? You're scared to raise your hand. Don't be scared. It's okay. Okay, so a few people aren't. Who is very comfortable with pandas and scikit-learn? Okay. Who has medium level of comfort? Okay. All right. So people are just not raising their hands. Good. So I'm going to assume people aren't super familiar. So who has never used Python before? No one's going to have that. Okay, cool. We've got a few. So it's a good general purpose programming language. What I'm doing here is some importing different libraries. And we said pandas is one of our most basic one. I'm importing it as PD. It's called an alias. And that's one of the speakers yesterday referred to it as the Swiss Army knife for data, Python Swiss Army knife for data, which I liked a lot. So it does everything working with data and tables, and its data frame object is, in particular, one of its main features. So I read the CSV file into a data frame, and then you can use the head attribute of that to look at the first 5 rows. And this data looks pretty good, but we see a few issues here. The column headers are not particularly useful to me. I've got some NaN values in here. My index, this bold font on the left is called the index, and that's not particularly useful either. It's just an integer. So what I want to do is clean this up, and based on my cookie cutter data ethos, then I'm never going to touch that raw data set. But the other part of that is you should always be able to easily reproduce any cleaned final data sets that you're using in your analysis. You should, and anyone else should. So based on that, we're going to make a script that's going to clean our data set, running it from the command line that I could use, that you could use, that anyone could use. And to show that, let's go back to our terminal right now. And if you want to run Python source data make dataset.py, and if you're wondering why I'm typing that so fast, remember the tab completes things once you start typing, so that'll make you a lot quicker at the command line. So we can run that, and I have some logging in there, and it's telling me reading the raw data, writing an interim data set, and then writing a final data set to data process. So that's pretty cool, and if we were following best practice, we weren't allowed to share our data on, put that raw data into the raw data file, and all they have to do to get my nice clean data is that one line, Python make dataset, hit enter. So one of the things I wanted to cover was how to make a command line script like that, and in particular a command line script that you can pass arguments to. So if I do make dataset -- help, you see this is my personal code that I wrote, but it has a nice professional looking help function, and it tells me the options I need. I can change that input interim or process file path if I want. I can change the index. I can either have it be the county name or the FIPS code. FIPS code is a 5-digit number that corresponds to the county name. So this is our first live coding example. We'll see if I can code in person. Can't even navigate folders in person, so apparently not. Okay, so we're going to go to source data, and then go ahead and open up make dataset and that click example.py. Your click example probably won't look like that. I think I was playing around in here and forgot to clean everything up. So this is the beauty of Git status. I can see the things that I changed that I should not have. So I'm going to say close this git checkout -- source data click example, and that's going to take it back to the version that you guys have. Okay. So make dataset.py, this is what I just ran that cleans up our data set, changes the column names to something more interesting or more usable. It does a little bit of data cleaning, does the re-indexing. And this @click stuff is what lets us add the arguments. So I'm going to delete all of this, and we're going to you can also open a new directory if you want. From scratch, we're going to do a click example to show you how flexible this package can be and how easy it is to use. So I'm going to import click, and then I'm going to define a function main, and I'm going to print, hi, my name is Erica, in that function. Does anyone know, it's another nice thing about Lab, Jupyter Lab, as opposed to the notebook, you can drag these and have side-by-side views, which is pretty fancy. Does anyone know what's going to happen when I run Python click example? Guesses? Is anything going to happen? So nothing's going to happen because I defined this function, but I didn't actually call it, right? So let's Python source data, right? Nothing happens. So what I want to do is actually call main. Reasons that I'm not going to go into right now because it's not super interesting. We're going to only run this main function. This is kind of the standard way to do it. You're only going to run it if you're running it from the file directly. So ignore that, basically. Okay, so now I'm actually going to run that. And I left out an equals sign. Right, so now it actually says, hi, my name is Erica. Not super fancy. But a nicer thing would be, of course, to pass the name to this function. Right, so I can tell it what name I want, and then I can do main of Erica and pass that. And then If I wanted to change it to the name of my co-presenter, she doesn't want to feel left out, we can run that and see, hi, my name is Catherine, right? Nice. The nice thing about code makes stuff like that easy. Okay, where do we want to go from here? I would like to be able to pass that name at the command line without ever having to look at that code or open that file. Is really nice if someone who doesn't know you, or you a year from now, which is basically might as well be someone who doesn't know your code, right? They don't have to look at the code. They don't have to know what you're doing. All they want to do is pass that file path and say, give me my nice clean data set. So we can do that by saying, and I always have to check the terminology, this @click.command is going to tell Python that I want this method to be a command line function. These @ signs are called Python decorators. You don't really need to understand a whole lot about them other than that they make the function they're decorating do fancier things. @click.command, and then I'm going to do @click.argument, and I'm going to add an argument name, and I can add a default if I want, which is what I did with the file paths. And then I think everything stays here. Then we take the name out in there, and when I run Python source data click example, you see it still says, hi, my name is Erica, but the really nice thing is if I run it and just put, whoop, can't spell, Catherine there and hit enter, it's going to automatically take that in, pass it to my function that I defined, and say, hi, my name is Catherine. Or I can put whatever gobbledygook I want in there, and it'll spit out, well, spit it back out at me. It didn't like the semicolon, though. It has to be a real string. Okay, any questions on that? So it's a really useful tool, and again, a thing that seems intimidating, but something that's great to have in your tool belt.
Is that good for, like, especially API calls? So you don't want to embed those in your code?
You know, I have not done a lot, like for making API calls or for creating your own API? Making API calls.
Because you don't want to embed, like,
Yeah,
password.
right.
You wouldn't want to put those in your code.
Yes, you could do it for passwords. It's a great way to do that, and you can actually make it like prompt you. There's also a super easy Python package I think called Password, where you just like type in password.password, and then it'll say enter your password whenever it gets to that point. Another thing, which again was in my bigger semester-long talk that I planned, is a config or secrets file that you would want to use. And you can keep all your passwords, AWS keys in that file. It's in your git ignore, so it never gets pushed. And it can automatically like import that, but it's only on your local machine. So a lot of options there. This is certainly one that you could use, yeah. Any other questions? Okay. This mic's really getting to me. Ignore my hunchback mic shoulder, please. Okay, so we now have a reproducible way to get to our cleaned data set. I was gonna do, how are we on time? I think we have, okay. I think we have time to do an example, or should I just keep? Okay. Yeah, I think I'll keep going. Okay. So we ran our Python make dataset.py. All the details are documented in the README, which is great. So anyone could recreate that data set from scratch. And so now we have our nice interim data set and our interim dot head. We can look at the first 5 rows of the interim data there. And we can see this is a little bit cleaner. I've got useful column names now. My index, instead of being an integer, is the actual name of the county, which is nice, but I'm still missing a lot of values. I still have all of my columns here. So then the final data set, which was also written in that command line script I just used, is I'm defining as X and reading that CSV in. And we see this is nice and cleaned. It only has the 7 variables that I'm going to use for the clustering. And I selected those using a combination of our business needs and some statistical analysis, which I didn't include in here. But this is a nice, right, our nice, perfect, clean data set. I also dropped all of the NaN or missing values. that was in that clean data set. If you do take a look at the length of the interim data set, we see there were 3,200 samples or counties in there. And then the length of X, my final data set, we're only at 3,115. So some rows were dropped due to missing values. If you wanted to fill those values in, you could fill them in with the mean or the median, but to keep it simple, I just said, if you don't have all the data, you're out, we're gonna drop those. Okay, questions? All right. So I always like to start with some exploratory data analysis. I'm going to go ahead and bring this up to full screen mode so it's a little bit bigger. In lab, the shortcut to do that is Command-Shift-D on a Mac, probably Control-Shift-D on a PC. Or you can just drag around to maximize. So exploratory analysis is not the focus of this talk, but I couldn't just slide by it without doing anything. So I used a library called Seaborn, which is imported as SNS, and it's a really nice statistical visualization library. You can see in just this one line, I passed it my code, and I get a really good idea of what the data looks like, right? I've got the histograms across the diagonal, so this is a histogram of median household income value, this is a histogram of my social associations, and then it does scatter plots pairwise of all of the other variables. So it's a super nice overview. I would do a lot more of kind of looking at means and averages and a lot of visualization before moving on typically, but not the focus of the talk. So definitely check out Seaborn for data visualization if you haven't used it already. It's a really, really nice library. Okay. So in our data still, oops. The next thing we're doing is scaling our data. So if we go back up to the top of our final data set, we see we have those median household income values. Those are on the order of 10,000 and something. The social associations values, those are more around 10, right? That's many factors smaller. And then all of the other values are 0 to 1, like not percentages, but decimals, right? Fractions of the population. So we've got a lot of different orders of magnitude in our data. And some algorithms are sensitive to that, some are not. K-means is one that is. So if I were to feed this data in as is, then everything's going to be clustered based around the median income because income is, as a raw number, so much bigger than the 10 social associations or the 0.0013 people that percent of people that don't speak English. So what we're going to do is scale the data using a standard scaler. This is from scikit-learn, is our standard Python machine learning package. I define that scalar. This is called instantiating. So you define that scalar, and then you can fit and transform that data. And now I see that X scaled looks like a big blob of numbers, which is not super interesting. So whenever I get these matrices or arrays back, I like to put them back into that pandas data frame. Remember, pandas is our data Swiss Army knife, and data frame is their way of working with tables. So I'm going to pass all of these numbers that are a little scary to look at into a data frame. They should have the original columns and index of my data set, so I can tell pandas that. And now, if I look at the scaled version of X, it's a lot nicer to look at, right? You can breathe easy. So you've got your variables, your index, and you can see that everything is looking like it's pretty centered around 0, so we scaled it to have a mean of 0 and standard deviation of 1, which looks about right. But we like to check that, and throughout my coding, I like to do some basic sanity checks. So we would hope that after we scaled our data, the means would be close to 0. That's what we thought we were doing. So let's take a look at, this is a nice pandas feature. You just say .mean, and it tells you the mean of all of your columns. And you can see that they're all very close to 0 there. So we're good. We feel good about that. The standard deviations should all be 1. Again, we see that they're all close to 1, or exactly 1. Excellent. So we feel good about that too. Any questions? Yeah.
For scaling, I noticed some of those values are negative.
Mm-hmm.
Are you trying to scale from like -1 to +1? Or I've usually thought about scaling from 0 to 1.
Yeah, it depends, and that is a way to do it. But yeah, this is scaling to a standard normal distribution, which is going to be centered around 0, and it'll actually have values bigger than -1 or +1, but the standard deviation is 1, which means what, like 67% of the data will be between -1 and 1, and then out from there. Yeah, so there will be negatives. And some algorithms you may want to scale to 0 to 1, it just depends. Any other questions? Okay. So something really nice that I like to do, again, for when you're going back and looking at this code a year later, you don't really remember what you're doing, instead of just printing out these numbers and saying, oh yeah, they look like they're close to 0, we can use what's called an assert statement. So I'm going to assert that when I look at those means, x-scaled means, and I take the absolute value of them because some of them are slightly negative, I want them to all be really close to 0 with some wiggle room, so I'm going to say less than 10 to the -15th. And I want all of them to be like that. So I'm going to assert that this statement is true, and then I can write my own little error message in there saying, your mean should be 0 post-standardization. And when I execute this cell, nothing happens, which is good because I asserted something that was true, so nothing happened. If I were to assert something that were false, so I changed the direction of that, I would get an assertion error, and it's going to tell me, wait, you said mean should be 0 post-standardization. Something's kind of messed up along the way. So this is like a baby intro to testing, even if you don't do formal testing like we're going to cover in the end. I like to kind of scatter these assert statements through my code as basic sanity checks, and writing your own error message is particularly helpful if you're running something from the command line. You're not seeing the code, but it'll pop up and tell you like, oh wait, you thought this number of rows should equal this number of rows, and maybe take a step back and something's funny. And so again, this is what our final scaled data set looks like. And we finally are getting to the machine learning. So it's a lot less fun and snazzy than machine learning in one line, but it's also a lot more understandable and useful. So for k-means clustering, as I mentioned, you do have to specify k, the number of clusters. And we're going to select that final number of clusters using the elbow method. Are people familiar with elbow method? Used it before? Okay, a couple people have. So the way you do that, we're going to run the clustering for k in between 2 clusters and 20. And so I'm going to run that for loop. It takes a minute, so I'm going to go ahead and get it started. And I'm going to run this k-means clustering for each of those clusters, and then I'm going to take an error measure, which is called inertia in scikit-learn. It's the sum of the squared distances from each point to its cluster center. Just a measure of error. And as the number of clusters goes up, that error measure is going to go down, because if you're a mathy person, you're getting more clusters, so the distance from each cluster point to its cluster center is going to be smaller because you have more cluster centers, right? So our errors should be decreasing every time, so we're going to plot all of our sum of squared errors versus the number of clusters, k, on that x-axis. And we're going to look for an elbow. We literally just mean an elbow like on your arm. This is not an exact science, so it makes some numbers people uncomfortable. But you see, with each cluster error, that's good. But at some point, you're going to get diminishing returns. So I've added a cluster, my error goes down. Add a cluster, my error goes down. Add one here. Here, at k equals 6, I add a cluster, and my error goes down, but not as sharply. So that's a point of diminishing returns where I added another cluster, but I didn't see as much payoff for that. So that tells me that's kind of a natural breaking point in the numbers and the number of clusters that I'm looking for. So we're going to go with k equals 6 for our analysis based on this elbow plot. Questions? Okay, so we'll train our final model here. Again, these are scikit-learn. I feel like for the people who have not used pandas or scikit-learn, I'm going through this really quickly. Are we sure there are any questions? Someone ask a basic panda scikit-learn question. Oh, you guys are killing me. I used to teach college, and this is bringing me back. You're slightly better than the 8 a.m. freshman calculus students, but only slightly. Nobody has any questions on pandas scikit-learn? No question is a dumb question. And now I'm going really fast. All right, I tried. Okay, So I've got my standard scalar that I'm defining again. I've done this a few times. I'm going to fit and transform it. And then with my number of clusters equal to 6, that's just this k that we've been talking about. It's the same thing. And then I'm going to fit and predict that model. Okay, and you can see I've got another array here, just like the one we had in our one line of Python, machine learning in one line. Those are all the cluster numbers. So now what I'm going to do, as someone mentioned, your numbers in that array may look different from my numbers, and that's because of the random initialization of the method, the clustering. Even though you're usually getting the same clusters, the order might change. So all of my code from here on out depends on the order that happened the particular time that I trained this last month. So I'm going to load my old model. And again, this is all included in the GitHub repository. Again, not best practice, but it's small, and I wanted to make it easy so you can load my old model too. Execute this cell, and we're going to talk about how to do that later, but I want to understand the results first. So pretend that we just trained this live, which we did, and then I just loaded a new one. Okay, so I'm going to set my predictions. This clustering is my trained machine learning model, and then all I have to do in Python is say .predict, pass my data, and it's going to give me my predicted clusters, which we've seen a few times before. Again, this isn't super useful. Anything we could do to make this more useful? Any ideas? Where do those predictions belong to? What does that 0 belong to? Accounting. Sure. We don't know. It could be accounting. So in order to determine what sample I'm talking about with these clusters, I'm going to pass them to a series, and I'm going to label them with, remember we're trying to cluster counties, so I'm going to label them with the county, the name of the county that went with that cluster. So a series is Panda's one-dimensional version of a data frame. It's just a list of data with an index that tells you what data point you're talking about. It also has that head method, so you can see it's just one dimension. I've got my list of counties, and I have the cluster that they belong to. If we want to look at all of them, it'll give me a ... in the middle. But we see all of our counties and their corresponding clusters. All right. Pretty cool. We're kind of getting somewhere. I can look at Davidson County, see what cluster Nashville is in. We're in cluster 1. Does that mean anything? Nope, not really. I can also look at the percentage of counties that are in each cluster. Kind of interesting. So I see cluster 2 is the biggest cluster. Does that mean anything? Not really, no. So in order to understand what these clusters actually are representing, I'm going to take a look at the cluster centers. And that's an attribute that your trained clustering object will have. So, okay. Now you guys know what it means, right? Okay. Scale their data. Wait, where are we? Way down here. All right, cluster centers. Okay, so we're going to take that scalar and we're going to do the inverse transform and then just put it right back into a table that looks like that data frame. And I also shortened the column names to make it a little bit prettier to look at. And this fancy line of code right here is rounding the different numbers to different digits, again, just to make it super, super extra pretty to look at. All right, so now we finally to something. Does this mean something? Maybe a little bit more, right? We can look at this. We can talk through it. So this is oftentimes where I start finding meaning from the clusters, and we can go through and look at some of these. Like cluster 1, I see this really jumps out at me. They have a particularly high income, so that's something that we're going to notice. Cluster 5 has very high social associations. That's one of their defining characteristics. Anybody else see anything that jumps out? It's a little hard to tell. There's cluster 0, pretty middle of the road for everything, and it takes some time going through and actually looking at the numbers. But I did that along with some visualization. And we gave all of these clusters names. And this is how we got the personas, our member level personas that Catherine showed during the introduction. So you can do this with people as well. So I'm going to go ahead and add those names up there so you get a little bit more meaning onto our clusters. So we can see, I'm going to go ahead and do the visualization before I talk through the clusters in detail. This is another way to get some meaning out of your clusters. I'm going to go back to this Seaborn library. It's the same one that I used for that pair plot. and I'm going to do what's called a heat map. So it's going to be this table or matrix of data, and then it's just going to be colored by the size of the data. And I actually passed the scaled data in here, but then annotated it with the unscaled data. So that's what some of the fancy stuff is here, because if you pass the unscaled data in, you're going to have like one row that's dark purple and everything else is white, right? Because you have the giant median incomes and everything else is super tiny. So to see all the variance across the variables, you need to do this with the scaled data. So this, again, makes it really easy to look at. Average suburbia, these are my same values that I have at the top of this average suburbia table. It's showing me their mean income, their social associations, their access to exercise, whether or not they live in a food desert, whether or not they commute alone, their percent rural, and the percent of, or fraction of the population that lacks English proficiency. So it's pretty easier to look at this with the colors. So our first cluster was that average suburbia. You can see it looks pretty average. There aren't any colors that stand out there, right? Everything's kind of middle of the road. We've got our percent rural is average. The income looks about average. Our second cluster we're calling the isolated urbanites. So we noticed that they had a super high salary that pops out at us. They have a very low fraction rural value, and they also have pretty low social associations, which I thought was pretty interesting, thinking about living in an urban area, but maybe you have a lot of people, but maybe not a lot of places to interact and meet with those people. Our small town USA, we see these two guys kind of jump out at us. Pretty high rural. They have long commutes alone. And then they have a pretty good value for access to healthy foods. So they have like probably a grocery store in their town, which is great. They can buy vegetables, but they're not doing great with their access to exercise, right? So they've got a grocery store, but maybe not much else. Rural challenges is our next cluster. It was our highest percent rural, and you can see they really struggle with the limited access to healthy food. So these are people who are maybe really kind of out in the middle of nowhere, pretty far from a grocery store. Important social determinants of health. They also have a pretty low income. I think it may be the lowest income of all the clusters. You'd have to go back up here at the table to check that out. Yeah, they have the lowest median income. Vulnerable locations, what we see stands out there is our not proficient in English value, and also very low social associations. So if you're trying to figure out where to give resources, this is a population that might really need some attention. They have a lot of people who aren't proficient in English, and they don't have a lot of social connections or support, so this is a particularly vulnerable group. Yeah, that's weird. So they actually measure, I think it's like the number of social association buildings, so like a YMCA, a church, some sort of community organization, and they do some sort of per capita numbering of those. So it's a, yeah, it's not social media, and it's at the community level as well, so it's not looking at any one individual person that lives in that area may have great social connections, but it's just an overall measure, and that's what the CDC uses. That's where all this data comes from, and I agree, it's a little like, of course it's not capturing everything like all data. It's representative, it doesn't tell the full story, but it gives you a little bit of information. Yeah, that's a weird variable. It's a great question. And then our last cluster is the rural relationships, and they're really driven by that super high social associations value. So they've got probably a lot of churches, other places where people congregate, and then the very high rural value. Okay, questions on that? So now I've got some clusters with a little bit of meaning. And I'm going to do one other visualization, and it's going to be a scatter plot. So that's going to project our data into 2 dimensions using principal component analysis. And remember, our data is 7 dimensions because we have 7 variables. So I'm going to use a principal component analysis to project that down to 2 dimensions. And in fact, it's going to pick the 2 dimensions that capture the most variability or variance of the data set. And I can look at the explained variance ratio, and what this is telling me is that if I rotate my axes, and get 2 dimensions with the most variance, that first dimension is going to have 30% of the variance of the whole data set, and the second dimension has 20%. So using only 2 out of my 7 dimensions, and it's rotated, remember, so each dimension is like a combination of the other variables. If you're familiar with linear algebra, we're looking at like a linear combination of variables. I can capture over half of the variance of my data set, which is pretty interesting. So we're going to use that here just as a tool for visualization. That first principal component is a combination of, this means negative the rural value plus access to opportunities plus median household income, and then some other variables to a lesser extent. Whereas my second principal component depends strongly on the inverse of having a long commute driving alone, plus some social associations values, and plus some limited access to food, and then again, the other variables to a lesser extent. So this is putting the data into a nice data frame so you can see the index. I've got the value of the first and second principal component for plotting, and now I have the persona name here. So, sorry, I still have persona from when we were doing our member level statement. A few of these things slipped through, but our cluster name. And you can look at Davidson County, and now instead of just seeing cluster 1, you can see Davidson County, we're in the isolated urbanites cluster, a little bit higher income, not as many social associations per capita as other places have. And if you look at another nearby county, Dixon, surrounding county, they're more of the small town USA, a little bit lower income. They've got a grocery store, but not a whole lot else, not as much access. So that's nice, a nice way to be able to look at county by county. And then the scatter plot, this is our principal component view of the data. You can see the counties on there. This is our first principal component, which we said was the negative of rural, which means more urban, more exercise opportunities, and higher income is displayed along this x-axis. And the y-axis, we're seeing a better commute plus a combination of more social associations and more of a food desert, so more problems with food access. This kind of makes sense. You can do, again, sanity check. Looking like this extreme cluster, red is our isolated urbanites, and we did indeed see our urbanites are more urban, and they tend to have that higher income. So you can see kind of how things fall out on the graph. It gives you a little bit of an idea of visualizing 7 dimensions down to 2, which is a tough thing to do. And you see there's a lot of overlap, so of course there's 50% of the variance that in just these 2 dimensions. Okay. Any questions on this? Yeah. Yeah, so that's from up here. The when I run this PCA fit transform, I saved it in, yeah, the PCA is defined here, and then it stores the components in that PCA object. And so I looked at PCA.components is going to tell you what the combination of variables is for each component, and I just sorted it. This is like fancy pandas sorting, ordering, so it's going from highest to lowest, magnitude, absolute value. And so it shows you in that PCA variable. And any of these things, like if you're looking at this later and you wanted to see Python PCA, you can look at, the scikit-learn has excellent documentation, and this is the kind of thing where obviously a 90-minute tutorial, especially if you're a beginner, is not going to make you an expert on this, but it's going to give you resources and hopefully get you comfortable enough to like Google and break things and go look at this and say, oh, well, I know I can get the components from PCA, I know I can visualize, and I can look down at this documentation and see, oh, PCA.components, principal axes and feature space representing the directions of maximum variance, and the components are sorted by explained variance, and kind of read through that. And like Google the words you don't know, and you're going to find yourself like 18 tabs deep in a maze of Googles. But this was, if you're feeling a little bit overwhelmed, that was me like a few years ago, and eventually you'll quit Googling as much, and you'll kind of realize you know a little bit what you're doing. You'll always still be Googling some, though. Yeah.
So my understanding of PCA was that it was like new feature engineering or like feature selection.
Mm-hmm.
So that's, I've never seen it like done
Yeah, I'm just using it. You can use it for feature selection, and you can reduce your variables using PCA and then feed those into the clustering. The reason I don't like that for this particular use case is the variables are so important to understanding the cluster, and we want to be able to tell our business this cluster has these high social associations, low income. If I tell them this cluster is high in the first principal component, it's not, my marketing people are not going to be super excited about that, right? For a model where you don't need as much explainability, or a supervised model where you're predicting something, that's a great way to do it. So here I'm just doing it mostly for the visualization, not for feature selection, but as an excellent point, another way to use principal component analysis is to reduce your number of features initially. Yep.
Did you do the analysis to see like what the clusters would turn out to be if you chose 5 or 4? So you give your marketing people fewer personas?
Yes, we did. And we actually initially had, for our person-based clusters, our member-level clusters, we initially had a 3 and a 5 cluster option because we kind of saw some elbows at 3 and 5. What turned out happening in that case was the 3 clusters weren't particularly interesting. It was basically like unhealthy, kind of healthy, and really healthy, which you don't need a clustering analysis to tell you. But once we bumped it up to that 5 clusters, that's where we started getting a little bit more insight. But we did run it with a few different ones, and I also saw like 12 was a natural grouping for our member level clusters. And I did those, and that was too much for us right now. We did not want 12 personas, so that one didn't make it very far. But yeah, and that's really another thing that's very, very flexible and fuzzy with this clustering. You can change the number of clusters, play around with it, change up your variables, which if we have time, I was hoping to give you some time to try to change the variables in that make dataset function and maybe run your own clusters with new variables. So we may have time for that. Yeah.
So when you select your amount of clustering, when it comes time for you to justify the amount of clusters you chose to whichever business unit requested this analysis, especially since there's a lot of subjectivity that goes into it,
Yeah.
how do you usually best justify your decision?
Well, a lot of it comes from the business to begin with, and I feel okay with that, right? If they tell me we need 5 groups of people, we can't handle any more, tell us the best way to organize your 5 groups of people, even if that's not the best natural data way to do it, that's okay, because that's what they need. They want to market 5 clusters, so I make that as data-driven as possible. For the most part, statistical and mathematical justification, I feel like my conscience is stronger than anything that any C-suite management person is going to ask me, so I don't have to give a lot of justification, right? They're going to trust me. I don't know if anyone was here last year. Someone gave a great talk on presenting your results to higher level management. I think her name was Sandra McRae or something. But her thing was tell them the time, not how to build a watch. So I actually try to keep those details out of that presentation, because if I start justifying like, oh, this is my elbow method, like, isn't this great? Great, eyes are gonna glaze over. You guys are interested in that, and I even get a few glazed over eyes. So I tell them the time, I tell them math loosely told me 5 clusters is the best, and occasionally you're gonna get some questions, which I love, but for the most part, you're not gonna need to justify that. Yeah. Yeah.
For the social connections you mentioned earlier, the county data supplemented with, let's say, the social media data.
Yeah, you could definitely pull a lot of other data in here to supplement with. Social media data, there's so much hype around it, but I find for our business it's not particularly useful because we're dealing with individual members, and I don't have a way to link their Twitter with them unless they give that to me, and we just haven't found a great way to really bring it in or monetize it. And a lot of Twitter data doesn't have location-based tags, so you can't even do it at the location level. So I do think there's a lot of value there. I haven't quite figured it out yet, so if you have, let me know. But another thing you can bring in is census data, which comes in at the census tract, which is a lot smaller than the county level. So that's another really nice public data set to work with. Another question? Yep.
You guys somehow are connected to people's devices too, right?
Yeah, we use Validic to get device data, and we did do some clusters with like, you know, numbers of steps and hours of sleep, and we've done a little bit of that as well. Yeah, we did look at the outcome, and we, like our super exercise, we haven't, I don't think I've done the social determinants of health with the device data yet, but our initial clusters had like a super exerciser, and we saw from their device data that they were getting 1,000 steps a day, and I think 3 to 5 times the average of the next closest cluster. And we also correlated it like with our business and saw that they're more likely to do certain things in our app and our UI.
Just as a follow-up, when you do that time analysis, is Pandas on your laptop big enough, or do you run into places where
Yeah.
you have space in Pandas?
For us, it is. We have, what's our number of lives right now? 11 million. So I can, at the moment, fit pretty much everything in memory most of the time. We do have a data mining server that I'll, you know, kick jobs off and let them run like overnight sometimes. We haven't really had to go to big data yet. I think we're getting close to that with capturing a lot more like click and view and interaction data. That's gonna scale up really quickly. But yeah, right now I run everything either on my laptop or just a not super huge data mining server. Great questions. Anything else? Okay. All right, so we've got our clusters. Now what? This is where we're like really into the last mile, right? You've got analysis that you feel really good about. This seems pretty interesting. You've got some results. What are you gonna do with it? So one side of that is you can like present it to your business. You can hopefully get someone to make some business decision based on your super cool analysis. That's more of the tell them the time, not how to build a watch kind of talk, and that is an entirely different talk, right? But the other way to walk that last mile is to use your results in an application, a UI, an app, some sort of user interface. So we've got our model, but we're not really anywhere close to using it in a user interface, right, to getting it implemented. Sorry, need water. Questions? Parched. Okay. Yeah, oh, sorry.
So you said the output from K-means, the cluster number is not always going to represent the same group necessarily. Is there a way to store the parameters that put
Yes.
into each cluster so that you can track what they're on?
Yeah, parameters that do that, that's a good question. But what I'm gonna do next is show you how I save it so that I can recreate that order. As far as the parameters of the algorithm, I don't know that there's a way to do that, but that is exactly where I'm going next, so that's perfect. So I want to save this nice k-means model so that I can use it on any other machine. I can pick it up later. I can make these same predictions in the same order. I don't retrain it and get everything confused and turned around. So what I'm gonna do is create something, this is called a Python dictionary, as a set of keys and values. So the keys are all of these strings on the left, the scalar, the k-means, the input format, the label mat. And then the values are these Python objects. This is my scalar that I trained. This is my clustering object that I trained. These are my columns and my label map. So I'm defining this final clustering object. And I can take a look. You can access the value just by typing in the string there. So if I look at final clustering at k-means, it tells me, oh, this was a k-means algorithm that you defined. I think it has the number of, yeah, it has the number of clusters on there. I was wondering if enough initialization details to retrain it exactly the same way would be in there to your question. I really don't know if that's a way, if there's a way to recover that, and I'm curious now. It's not easily displayed there. And we can look at our scalar, right? We need to scale the data in the same way, that's there. Our input format, if I want to pass new samples and get their cluster value, then I need to know what order the variables were in. And then finally, the label map. So this is my my way of dealing with the ordering. So we've saved our model. So in this particular model, the numbers are going to be in the same order every time, and then I save my mapping of what I understood about those clusters and what I named them. So I know that cluster 0 was our average suburbia, cluster 1 was those isolated urbanites. Okay, so I've got everything I need to use this model in just this final clustering dictionary. And then I can use a Python library called Pickle, if you're familiar with that. If anyone's familiar with Java, they use jar files to serialize objects. So Python's version of that is Pickle. It's like a pickle jar. You pickle things to save them for later. Python's a very cutesy language. So you open your file path, and this is just saying open in a write binary mode. And then you use your pickle package. So you pickle it, pickle.dump, super elegant. You just dump your final clustering Python object that has everything you need into your out file. And it's saved as a file. I could go into my file browser and see that, but I'm not because I'm running short on time. Okay, so I'm going to save that. I called it example.pickle, so I didn't overwrite my actual one, but I saved the one that I trained in this exact same way. If I look, why is that? Oh, so I had run this, so this is defined already because I'd run it already. This was supposed to be nothing. Pretend that didn't happen. Right, and so then to reload the model, all you have to do is open that same file path. Instead of a write binary, it's a read binary, and it looks really similar to the saving method. You do a pickle.load of infile, and you see the reloaded model variable now has the same keys. You can access all of those same objects. And that's a file that right at the most basic level, you can like email it to someone and have your like your IT people get that into production. So this is a file, you can use it on hopefully any computer. This is how you all got the model on your servers today, is this pickle file. So that's great for saving your file. Okay, got 10 minutes left. All right, I got through a decent amount. We're running a little tight. Okay, but I have this file, right? But I still need to be able to load that pickle model and maybe pass it data and give that to my UI or my backend so that the system can use those results somehow. So I do that using a custom module. So if I go to source and models, because that's where our code regarding models lives, I usually use something called an analytics manager. Are people familiar with classes, software development in the class sense? Okay, a few people. So I wrote this as a class. If you're not familiar with that, you can do pretty much the same thing just with function definitions. But the important thing is I want to be able to give my model, where my model is saved, and then some sort of new input data to be classified to this method or to this class. And then I want to have that class do everything I need to take it from reading the model, reading in that new data, telling what the classifications are, and writing them out. And so that's what all of this is. I define how to, so one more thing with the data. Right now I'm just using a fixed file path with some new data. In our real production, we would be pulling new data from our servers. So in addition to this analytics manager class, I would have a database provider class that would be pulling that new data. So our great IT guys have a nice staging table where I get the updated data every day. We run it in a batch every night. I pull that in and pass it to this analytics manager, so it's doing some new clusters. But here we're just doing this flat file. So I define how to clean that new data that I'm pulling. I want to do the actual prediction, which is the scaling transform. K-means at predict, and these are, remember, our saved model. We access the scalar using that dictionary notation, and then I can just do the dot transform because it's already trained, it's ready to go. I can then map the labels to what they are, and then I just put all of that into a process method. So we read the data in, clean, predict, return those predictions, and then I would normally have a write results where we would connect with our database provider, and I would dump that back to a staging table. The IT guys would do some checks on it, make sure it looks good, and pass it to our front end where they can access it and use it to order content that we're showing members. And just to show you how easy it is, let's go back to our terminal. Command Shift, escape. Sorry, trying to get back to single document mode. So I can run Python source model analytics manager, and that's all I have to run, all my IT person would have to run, and I'm here, I'm just printing those results to the screen. But if you have a little bit of code, you have a database manager, instead of printing to the screen, you just insert them into a database and they're ready to be used. And this is again where many ways to skin a cat. This is not the only means to get a model into production. Obviously, there are about 1 million others. It's not even the best one, but it's a pretty, necessarily, right? But it's a very straightforward one. And you actually have your machine learning model being used by your product. Okay, 2 minutes left. I promise I'm gonna give you like 2 minutes. We've had questions throughout, so I don't feel too bad not leaving too much time for questions. But I really wanna talk a little bit about testing. So I've got these nice clusters. How do I know that they're right? Any ideas? We wrote a lot of code, right? And even the code we didn't write today, like look at all this junk in here, this whole class, it's all pretty straightforward, but there's a lot of it. So how do you know I didn't make a mistake? And how do I know I didn't make a mistake? So that's where testing comes in. And has anyone done like test-driven development? Any software developers in here testing? Okay, great. Oh, awesome. That's more people than I thought. Okay. Are you guys cringing right now? Anyone really upset at me? Do you know why? It's because I'm doing the testing at the end, which is a no-no. In real test-driven development, you write your tests first because that's what you want to like get to. But I'm not a real developer. I'm a data scientist, so I usually write my tests at the end. And I think there's a big angry Stack Overflow post on this, and I thought a nice response was that the best time to write tests is at the beginning of your project, but the second best time is now, right? So start them anytime. Okay, so just to show you how super, super easy this is some imports. I use something called PyTest, and PyTest uses, it's what we installed at the beginning, something called test discovery, and what it looks for is any file that starts with the word test, and then within those files, any method that starts with the word test. So when I just type PyTest at the command line, it's gonna look through all of those subdirectories for any file that starts with test, and it's gonna run any method that starts with the word test, and these assert statements that we talked about before, it's gonna check all those assert statements and make sure that they're true. So this is a super basic one. I set sum result equal to 2 plus 2, and I want to make sure that sum result equals 4. So I run PyTest, does some things. It gives me this nice green thing that says 1 test passed in 0 seconds, which is great because 2 plus 2 does equal 4. If I wanted to check that 2 plus 2 were equal to 5, I run PyTest again. Ooh, it gives me this scary red stuff and says, wait a second, it tells you exactly where your code was broken. I'm asserting that 4 equals 5. That is wrong, and we need to fix it. So the way I do this for, oh man, really running short. The way I do this for these clusters, okay, so I'm going to go back to what this looked like before. I added these 2 tests where I have a fixed sample data set where I put my cluster centers back into that data set and run them through the whole pipeline. So my cluster center for my isolated urbanite, if I run it through my whole pipeline, reload my model, remap the names, it should give me back that same cluster, right, if I'm putting in the middle cluster. So I have this little tiny test CSV file, and because I wrote this nice analytics manager, it only takes me 2 lines to run that test CSV file through that whole pipeline that we defined, all of that code, and then I know the order because I set these tests up, and I know that my first sample is the cluster center for the isolated urbanites, so I know it should tell me that that's an urbanite, and then I was going to do these separately. I know that the next 4 should be all of those guys, and so now we run PyTest again, and you should be able to do this on your laptop as well, and notice we have 3 tests passing instead of 1. Okay, Catherine, I left you 3 minutes to close. And then we may have time for like 1 more question.
Yeah.
We'll see.
Hello. Oh, yes, it did. So what you saw here was all the stuff that's sort of in the background. And then what we want to talk about is, so then what do you do to get it in your business? How you get your business to actually use this? So we have a couple of challenges I wanted to point out. One thing was requirements were not well defined, which is a super generous term. Requirements basically weren't given at all. It was something like, hey, can you make this more personalized for us? I mean, that was literally the conversation I had with our VP. And I was like, yes, I will. And then we went back and talked about what we did. And so it was a process where we kind of went through, we brainstormed, we came up with some ideas, we iterated with the senior leadership team to say, here's what we might do, does this work for you? And kind of went back and forth. So if you're in a position where you may be closer to starting out on some of these data science things, this may be a process you have to go through. I would say giving people things to react to, coming up with ideas, and then presenting it gives people a little bit more place to go when they're having that discussion with you, because a lot of times they know they want to say, you know, if I'm talking to you, if you're if you're the people who are doing this in the business, they'll say, we really want to use big data, or we want to use machine learning, we want to do data science, and they don't really know what that means. They just know they want to do it. It helps them give some language if you can go to them and say, here's what this looks like, here's how you'd use this in the experience. So that was one of the challenges we had. The other challenge we had was that in our organization, data science sits outside of IT, which for us is appropriate. I don't know how it works in other places. I've seen it inside IT, I've seen it outside, just depends on what works for you guys. But what that also meant was that we were outside of the software development lifecycle. And so we had a lot of pushback from our IT group, understandably, because they were like, we do things that product gives us to do, because that's what we've been told to do. And I was like, but I'm telling you that the CEO did this and said to do this. So we had some arguments. It's fine. We're all friends. With appropriate boundaries now. But what has happened is, and that, yeah, sort of, we let them. But what has happened is really one of our second successes here is that we are now more integrated into that software development lifecycle. We're more tied to product. We actually just had a new intake process worked out, and that has helped us be part of that whole process so that it doesn't feel like it's this rogue thing that's happening on the side that we're jamming into their schedule. The other success we had was that there was high interest from the business. So again, they want to say, we do data science, we do machine learning, we use big data. And so even though we were sort of outside of that process, it gave us some of that priority, and we had the backing of the senior leadership team so that we were able to get these things done. And that was a big part of this too. So if you're starting out on some of those things, you need to make sure you've got executive level sponsorship, and you need to be able to give them the language they need to talk about these things. And then did you talk about the last mile being talked about?
Yeah, mentioned it at the beginning, but again, that last mile, right, it's so much easier to walk if you set yourself up for success. You really walk the first mile correctly, define your problem statement, set yourself up with clean code so that your solution is robust and you feel confident enough to put it in front of a client or a member and actually have it in your user interface directing where things go.
Yeah. And this has been a huge momentum point for us with sales. We've had a lot of sales. I've started becoming part of the sales team now, unofficially, because this is what the market reacts to. They want to know that you're using data to drive your innovations. They want to know that you've got people who are doing things that are sophisticated and that you're working on things in a really analytically driven perspective. So if you can wrap things up in a way that people understand, like she was saying, you know, use these visualizations. I don't know if that guy's still in here. Jay Roy did a presentation yesterday, and he was saying the same thing.
Yep,
there you are. It was great, by the way. But it was that part where you're talking about, don't show them all this crap that it makes sense to us. Show them what makes sense to them and helps them digest something really easily. That will go a long way to you getting to this stuff into production. That's it for today.
I think we're out of time, but feel free to come up if you have any other questions or email us. Yes, I do. Do you want to take my hunchback off?
There you go.
No, I hope I didn't sweat on it.